What's poppin', dogs? Mr. Allen here with some ACT geometry prep in this video, and we're going to be focusing on circle problems for this one. And believe it or not, there's a wide variety of circle problems that you can encounter on the ACT. I mean, I've got radius chord relationships, we've got circumference, we'll also talk about area with that one, equations of circles, totally different than any of the other ones, and then also some angle relationships that you're going to find in circles. So let's get it started. A chord 24 inches long is 5 inches from the center of a circle, as shown below. What is the radius of the circle to the nearest tenth of an inch? Okay, so when we're talking about a chord and its distance to the center, it's measured perpendicular to that. So what we have here is actually a right angle and a right triangle within this circle. Well, I've got 5 right here, and another thing to remember here is that when I draw a radius, because you can extend that through that chord, it bisects that chord. I'm going to get rid of that right now, but it bisects it. It splits it in half. So I've got pieces that are 12 and 12. Now, if you remember your Pythagorean triples, this is a 5, 12, 13 triangle here, and this bad boy is done. And if you did not remember that, the answer here is D. If you did not remember your Pythagorean triples, you can always do 5 squared plus 12 squared equals C squared, right? 5 squared plus 12 squared equals C squared, and just go through your normal Pythagorean theorem. But for those of you that are like, wait, triples, what are those? Let me write them down for you guys, okay? So you have your 3, 4, 5 triangle, 5, 12, 13. Then we have 8, 15, 17, and 7, 24, 25. Those are the 4 most common triples that you're going to see pop up on the ACT, SAT, even in calculus. Those guys come back all the time. There are other triples that exist, but those are just the most common. For this one, the ratio of the radii of 2 circles is 4 to 9. Right? They can be written as a fraction as well, or even with the word 2 between 4 and 9. What is the ratio of their circumferences? Okay. Well, circumference is 2 pi r, right? So if I'm talking about ratios, and I can write this as a fraction over 2 pi r, let's substitute the 4 and the 9 in here, and I think you might already see this one. It's just going to be 4 to 9. So we got 2 pi and then 9. There's multiplication that's implied between all of these. Well, my 2's are going to cancel. Boom. My pi's are going to cancel, and I'm just left with the 4 to 9. 4 to 9. So we've got answer G right there, which is good. What if this said area? Okay, so let's just throw that one because this one's pretty easy. But what if it did say area? Well, area, it's pi r squared, and we can throw down the same type of formula here. So I can go with pi times, we'll just do 4 squared over pi times 9 squared. My pi's are going to cancel here, and I'm left with 16 over 81 for that one. So, okay, so a little bit different scenario, but that's if it was area, okay? Now, one thing to note is this also applies not just to circles, but also to other polygons as well, like a square, a rectangle, triangle, whatever. If they say that the ratio, they're similar, and the ratio of their sides is 4 to 9, then their perimeters are also 4 to 9. But their areas are going to be 4 squared to 9 squared. So when we get into area, we're going to square those things. If we get into volume, we're going to cube those If we get into volume, then we're going to be cubing those ratios, all right? We'll save that for another problem, but that's a general idea right here. So a circle in the standard XY coordinate plane is tangent to the x-axis at 5 and tangent to the y-axis at 5. Which of the following is an equation of the circle? Ooh, I like this. Okay, so I'm going to draw this up. So let's get a little ruler action going here. So here's what we're saying. It's tangent right here at 5 and tangent right here at 5. So on my x-axis and my y-axis, this being my x-axis right here and this being my y-axis right here, it's tangent at those 2 spots. So what does that tell me? Well, that would tell me that my center here is at 5, 5, wouldn't it? And what's my radius going to be? Well, my radius is also going to be 5. So which equation does that match? Well, you do have to remember a little bit about your equations of circles. And I'm going to go ahead and write that down in a different color here. It is x minus h quantity squared plus y minus k quantity squared equals r squared. H and k are my centers. So this is h and this is k. My radius needs to be squared, so I'm going to square 5, which gives me 25. So my thought here is it's either D or E, but let's look closely at the equation. It's h or x minus h and x minus k. Therefore, it is choice D right here. There we go, man. That's actually that's a good problem. I've seen that one a couple times, so definitely pay attention to that. When they talk about tangent and stuff like that, and you got to find the center. It's not just a dead giveaway on these things. So solid circle problem. For this one, in the circle shown below, M is the center and lies on RU and ST, those two segments, which are diameters. They pass through the center, right? Which of the following statements is not true? Ooh, these are always a little tricky, right? You got to think like, wait, that works. Wait, which one doesn't work? Okay, for the first one, it says angle TUM, which is this guy right here, is 65 degrees. All right, now this one is true, but I'm going to show you guys why. So let's zoom into the circle right now. If this is 50 degrees, that makes this guy 50 degrees, okay? Now, these are all radii. These guys all right here are all radii, therefore they are all congruent. And now I have this isosceles triangle. And in my isosceles triangle, the legs are congruent and the base angles are also congruent. So those two angles, T and U, are going to be congruent to each other. Well, how many degrees are in a triangle? There's 180 degrees in a triangle. So if I take 180 and I subtract 50 degrees, I'm left with 130. And if those two angles need to be the same measure, I'm going to take that 130, I'm going to divide it by 2, and we end up getting 65 degrees. So this one is true, okay? Maybe I should just cross it out because it is true, even though it's like counterintuitive there. Okay, so next one. TU is parallel, TU is parallel to RS. Is that true? Well, we're talking about these two here. TU and RS. So let me draw a line through here. We got this guy and we've got this guy. Whoa, that did not run with the ruler. There we go. Okay, so we're talking about those two lines. Well, again, we were just talking about like the isosceles triangles. Those two triangles are actually, they're congruent. So all of these angles are also congruent. So like these two angles are also congruent. Now, if we think about our parallel lines and transversals, I'm just going to pick one of these two, either ST or RU would do the trick. And if I throw those through, there we go. That is my transversal of those two lines that we're trying to figure out, are they parallel? Well, the alternate interior angles would be this angle right here and this angle right here, and they are congruent, therefore those two are parallel, okay? So let me clean this thing up here because we got a whole lot going on. So both F and G are true, okay? So we're going to take those guys off. So we'll go ahead and not our answer. Then it says arc TXU measures 50 degrees. So we're talking about this arc right here. Does that measure 50 degrees? Well, we did say that this angle is also 50 because those are vertical angles. All right, so or opposite angles, some people refer to them as. So they're congruent. And then the central angle is equal to the arc measure. So central angle equals arc measure. All right, so that's also 50 degrees. It's off the board. Next one, RM is congruent to TM. So RM, let me get a different eraser here. Here we go. Is equal to TM. Okay, so or congruent to TM. Let's see. That'd be RM, TM. Those are both radii, right? Off the board. They are definitely congruent. Then my last one being, hopefully this one is not true. RS is congruent. So RS, this guy is congruent to SM, which is this one. There is no information that tells us that. So this one is not necessarily true. We aren't guaranteed that that's going to be true. So no, 'tis not. All right. So it is answer K here. That did take a little while to get through because there's so many correct answers. But I think that's a solid review of circles, the angles that are in your circles, whether they're central, in angles, on angles, whatever. Very helpful review there as to how that all applies. And just a general reminder that all radii are congruent. You're going to get congruent triangles there and all that good stuff, all right? So hope that helps you guys. I know it's more information than, you really necessarily have to solve that one quickly. You don't want to take too much time on each problem, but hope that review helps and you guys enjoy the video and have a dope day.